Are able to hear me? Right. So yesterday our discussion was on the understanding of bias and variance. Okay. These are the two components what you should take very seriously when you're building your machine learning models. Anything affected by the state of importance can cause overfitting or underfitting in your particular criteria of your machine learning model. So whenever you're working with any implementation, your bias variance trade-off should be taken. So the bias variance trade-off is basically nothing but it's a balance between you need to always check that you're balancing between the bias and variance that a model must achieve the optimal performance. Now, people many times think that this is the corresponding value that is suitable for bias and variance. There is no specification like that. You should go on optimizing your model in such a way that your model finally can balance between the bias and variance, and then you are able to reach your target outputs very effectively. Am I clear? So if anybody says that this is a construct of the bias that we should control, it's a wrong statement. Be very clear about it. If a good domain expert and say like a subject matter expert is there, he can give you some value because of his experience. If he's giving that value, it's really good. He's saying that this level of bias and that specificational variance, if you are able to achieve, it's enough for me. He's really doing some great amount of help for you to see that you're balancing between these two. Very easily, you don't need to really think about it. Else, we have to always keep our focus on the target. And are we achieving that particular piece of the target or not? We should check and adjust the bias and variance values there. But here, one very important word of caution. We already said that our model should be generalized. Yes or no? So whenever your model is pushed into any new problem or any new insights, this trade-off balance between the bias and variance should not be disturbed. That is the most critical part. So one of the most critical area in AIML projects is optimization. So you should always check some small, I'm just giving you one tip off, just keep it in your mind. A good model should have low bias and low variance. Be very clear about that, okay? Any good model should have low bias and low variance, but achieving this is really challenging. That's what I'm saying. Optimization is one of the most typical subjects in your whole experience of AI ML. So once you start increasing your experience in the domain, your industry will check you're technically able to get through the criteria and composition of that balancing or not. Now, optimization is what they expect from you out of your whole experience. Be very clear about it. So there are constructive some trade-off illustrations I want to present. If suppose say like you're managing your low bias and high variance, means you have optimized your model and you tried, but what is happening is you're getting the low bias, but you're getting high variance. Then change the model and think very carefully where a complex model like deep neural network technically may fit the training data, but it may overfit and fail the generalization that is a high variance. Means you are fitting the process through some deep neural network like complex models. Because of that, technically you are getting the low bias, but it is overfitting you and making you fail to generalize, getting you through the high variance. So whenever high variance is coming, your model is not getting generalized. It is working specific to certain situations. Am I clear? Understand that. And then think seriously, what is the other alternate machine learning model that can fit to your particular application, which can help you in reducing the high variance. Now, there may be a case where you may have high bias and low variance. Means it's very clear. You're using a very simple model like your linear regression, which may not fit the training data. Because of that, you're getting high bias. But its predictions are not fluctuating much with the changes in the training set. Means whenever you're making any changes in the training set, it is not fluctuating between the select the predictions. So that is nothing but your low variance. Here, what you should do, once again, you can think of changing the model only. Rather than keeping the construct of the lower level model like linear regression, better try to switch on to some neural network constructs. So is there any specific rule that this particular type of algorithm fits the machine learning model directly? No. Therefore, you come and answer different machine learning algorithms in interview rooms. Will your interviewer feels really wonderful with human? Absolutely not. You should tell the trade-offs. Therefore, the challenging questions you'll always face is, how did you plan to adjust these bias and variance constraints? Now, the third case is low bias and low variance. This is the most ideal scenario where the model is capturing the true underlying patterns and it's generalizing well to the new data that is fundamentally coming here. So the more we work in AML models, don't you think that the more we will start getting addicted and select expertised in the construct of bias and variance management or not? So if I give you any fundamental example in implementation, man, my example, once it is pushed into a model and the steps are done, and we are able to put the training and test data and we are able to check the accuracy levels and the loss factors. Is your responsibilities completed taking that particular example? No, the responsibility is not complete. Your actual responsibility starts from there. On the same program, what I gave you, what you should do, should go on checking yourself with the test and training data and know what are the optimized standards in adjusting the hyperparameters relevant to your particular algorithms to achieve the low bias and low variance. Are you getting me? That is only by practice. Means hours together, you have to sit and you should start working out on that. So where is the biggest difficulty in machine learning for students who are coming from the traditional software industry? Man? There, if we get the corresponding values, we leave the process. But here you should always go on practicing to check what are the fundamental mechanisms you induce into your code that can help you in adjusting the bias and variance. Am I clear? So how to find the balance now? How to find this particular balance? One of the technique we have that is called as cross-validation technique. So every model should be pushed into cross-validation techniques that can be used to evaluate the model's performance and find the right balance. What are the cross-validation techniques? They are once again certain kinds of algorithmic implementations, mathematically evolved, we'll check. Okay. You have something called as regularization techniques, where you will be applying the constructive test like L1, L2, where we will use this L1, L2 tests to see that we are controlling the variance and prevent overfitting. The third is, instead of changing the model itself, we'll try to adjust the model complexities. Okay, model complexity adjustment for achieving a better trade-off, in which technically what we will do is we'll try to prune the decision trees, means eliminate such features that are not essential, reducing the number of layers or neurons in the neural networks. So when your interviewer is asking you what are the different kinds of techniques you have been using for the construct of adjusting the bias or adjusting the bias and variance or balancing the bias and variance, or what is the technique you have used for bias variance trade-offs. On the high level, just see that you're giving these answers, okay? Now, sir, how exactly we can implement them? That is what we have to learn. That is the purpose for which you're sitting in these sessions, I hope so. Once I get into my practical side, I need to cover all these things, man. Not just the algorithm. That's what I'm saying. Learning algorithms is very easy. Are we learning those algorithms in such a way that we are really making ourselves mark towards the AI ML implementations? So graphical representation of bias and variance will be in which way? See, with values, you can never ever present the concept of the bias and variance. First, understand this. Even though with your final target value, what you're providing, accuracy, what you're presenting, with that accuracy, you can understand how much of loss you are having, but you cannot know exactly the situation where the corresponding bias and variance has started deviating. You cannot know. The deviating point is very important. Therefore, the best way to represent bias and variance is absolutely through chartsmen. We generally call this as bullseye analogy. Bullseye analogy means representing and presenting a correct chart or a graph. Am I clear? Just keep these points what I'm giving you, and whenever the charts are generated, just keeping these points, try to understand your model is going through high bias or low variance. Predictions are far from the target, but they are close to each other. One simple thing you can understand, you are having high bias and low variance. Your predictions are far away from the actual target, but they are technically close to each other. What do we technically mean is shots are close to each other, but not close to the center of that particular piece of the target. So what do you exactly mean by this? Suppose say like this is your fundamental chartman. Okay. When I'm generating my practical examples, I'll show you this. Now let us assume that your target point is this. Okay, this is a point you need to achieve the target. When your data points are supplied, what is fundamentally happening is your data points are very far away from the actual target. These are all experimental data, man. But they are very nearer to one another. Are you getting me? They are accumulating cluster, but from your target, they are very far away. Is that point clear to you? Means your data points are very nearer to one another, but they are very far away from the target point. Shots, here shot means each circle, man, okay, each data point. Shots are close to each other, but not close to the center of the target. This is your actual target value, what you should achieve. If your chart is coming anywhere like this, then you can come to conclusion that you're having high bias and low variance. Am I clear? Hello. Keep that very clear in your mind. The second thing, low bias, high variance. Your predictions are close to the target, but they are widely spread out. Means shots are hitting the center of the target, but dispersed around it. What we mean is, just watch carefully. In the chart, what you're generating, suppose select this is your target point. Okay. Now, your fundamental predictions, whatever you are taking, they are nearer to the corresponding target, but they are fundamentally spread out. Means your targets are spread out, they are not nearer. Are you getting me? Mean their distance is very far away, but they are all trying to move towards the target. Whenever your data points are moving nearer to the target, but your data points are spread very far away, then it is low bias and you're having high variance. Is that point clear to you? So looking through the charts and graphs, is it not more easy to technically understand what kind of bias and variance trade-off you're having? Now, the third is you're having high bias and high variance. High bias and high variance means your predictions are far away from the target and they are spread out. Means suppose say like you're having a chart like this. Now you are having your target point here, man. Okay. Now, technically what is happening is you are having your data points which are very far away, plus not only from the target, they are also very highly spread. Am I clear? I mean, the distance between the data points is also very high, and their distance to the target point is also very high. Then it is very simple to understand that you're having high bias and high variance. Clear? So don't you think that charting can give some idea for us, man, where exactly our balance is mismatching? Now, the last is low bias, low variance. When you are saying that you're having low bias and low variance, now I think by this time your logic is clear. So like this is your target point. Now, your predictions, whatever you are trying to take, they are very nearer to the target and they are also close to one another. Are you getting me? Sometimes they may be overlapping. So as you're training, by looking into the corresponding scatter chart, that's the reason scatter chart is very important for machine learning one. So by looking into the scatter chart, are you not understanding exactly how your trade-off is about to go and where you need to make which particular type of fundamental differences? So look into these particular factors very clearly and start moving through the construct. Are you getting me? So your predictions are close to target and clustered together. So shots are tightly grouped and hit the center. Be very, very clear about it. So you need to just understand the construct of the process very carefully in the criteria, man. Are you getting me? So now, don't you think that we need to have some clarity on the construct of the different kinds of training algorithms that can come and the optimization techniques that could be coming into the picture. Just beyond the line when I'm having some issue with the net. Okay, I'll make a correction. Are you catch me? Okay, are you able to hear me now? We had some issue with the network. So whenever you're working with a constraint of adjusting your bias and variance, which is very important area with respect to your criteria of your machine learning. Are you understand the importance of a bias and variance now? Means your whole optimization techniques depend and they will be surrounding around these two factors only. So what are the different means when you're training your algorithm and your optimization has to be achieved, what are the training algorithms and optimization techniques we have to keep in concentration? First thing you should understand, no algorithm will learn how to achieve the corresponding optimization or accuracy in one single execution. So during training, algorithms always learn by iteratively adjusting parameters to minimize the error in predictions. But here try to understand one of the most challenging factor, man, okay? You are executing your first time machine learning algorithm, keeping the target here, okay? Target is identified. Target is fundamentally identified to be here, okay? Now, after you run your algorithm, what happened is you found your data points. You found your data points. Technically, they are very close to one another. In this way, they are spreading. Okay, just try to catch me. They are fundamentally spreading like this. Means what is happening? They are nearer to one another. This is what we are trying to observe. Yes or no? But technically, they are very far away from the actual target. Do you agree with me? Now, whether it is high bias, low variance, low bias, high variance, let us forget about all those things. But finally, you should conduct your experiment once again such that these data points will come nearer to the target. Do you agree with me? Now, is there any straightforward formula you can give me when these points can adjust nearer to your target? Technically, no. Second thing, try to understand common sense. Now, I am trying to pull this data point, concentrate. I'm trying to pull this data point in such a way that I have to decrease this distance. Yes or no? I have to decrease this distance. I have to decrease this distance means maybe I need to increase its value or maybe I need to decrease its value. Do you agree with me? Now, let us say like I found that if I decrease its value, this point is trying to come nearer to this. Now, if I put the same value on this data point or this data point, will they adjust in the same way? No. Now, what is that value to adjust to all these data points in such a way that they should technically come nearer to the target? That is learning rate. Means you should give some learning rate as a ratio. That ratio, when you apply on these data points should move towards the target. Am I correct? If it is a single point, don't you think that's very easy for you to adjust the data point towards the corresponding target? And all the data points are exactly the same line of height, let us say. Then one single value for all the data points will adjust. But practically, these data points are scattered or they're very straight. Scattered. When they are scattered, can you give one single value for their adjustment towards the data point, target point? Therefore, what we should do during training, you should make your algorithm to learn by iteratively adjusting the parameters to minimize the error in predictions. Means there should be some kind of ratio what you should plan, and that ratio should be planned very carefully in such a way that you need to conduct multiple experiments. In these multiple experiments, in each experiment, what you're doing, you're adjusting the values of the parameters, seeing that you minimize the error in prediction. Means, don't you think that every time you conduct a training, the output of the training along with your target data point and the adjusted values should be once again stored and they should be studied for next experiment? You just imagine for a project like weather forecasting and automated cars or self-driving cars, how much data could have been generated by these companies, man? Only learning data with training data, and the training data adjusted with optimized data, how much amount of data could have been collected? You just imagine. To handle all this particular kind of data for making your experiments to work very perfectly, again and again with millions and trillions of data values that are getting generated, don't you think that you need some area of big data definitely into the picture? That's what I'm saying. Doing AI ML in your personal machines is very easy. You should practice on machines, but keep a broader thought process towards your industrial standards. So the iterative process involves optimization techniques. This iteration, whenever you're conducting, should conduct the iteration by using some kind of optimization techniques. Therefore, iteration doesn't mean that you just blindly do the epochs. Am I clear? So people generally think that machine learning algorithm should be iteratable, means they just try to write some loop and they keep it in the loop for 10 times. What is the use if you're keeping in the loop for 10 times? If you are not writing any optimization technique through which every time you iterate, it means you are conducting the experiment once again. What is the use of conducting experiment once again with the same values what you had in the previous level of experiment? So don't you think that every machine learning expert is just like a research scientist? The only difference is the other research scientists could be working in the laboratories, man. You're working on your machines with your programming skills. You need to just understand that. You just go back to your schools or colleges, man. Whenever you're part of the chemistry experiments, man, did you take the chemistry experiment data and you started recording it with only one time conducting of the experiment? No, even if you got the exact value in the experiment with titration, don't you think that your professor used to say, please do 3 times and give me the average? Why we do it? Don't you think that when you're conducting your first time your experiment, you will be having that particular indicator color different. When you take that indicator color to your particular professor, he used to guide you. Yes or no? You have kept that particular indicator, maybe 1 drop extra, man. Please see that you're trying to control the amount of volume of the drop this time and see that it's less. You're getting some other color. He used to tell you that now you are given less amount of criterial indicator. You please. So generally 3 experiments we used to conduct only to reach that particular target. But whenever you're conducting the experiment, were you not taking the precaution of adjusting the corresponding volume of your chemicals? That is optimization. There you did the optimization physically, man. Here our computer program should make the optimization to happen. Therefore, iteration doesn't mean that blindly you take the same values and do it. Am I clear? Mainly, there are 3 kinds of optimization techniques. When one is called as gradient descent. So adjust the, when you take gradient descent, the name itself is telling you, it adjusts the parameters in the direction of the steepest decrease of the error function. Means what? Let us understand one small thing here now. Okay. Just watch my screen. We'll see all these things practically, man. Now, this is your target point, gentlemen. Okay. Now, many number of scatters are there. You found that one of your particular target value, one of your particular target value with your data point is here. It is in this location. Are you exactly nearer and matching to the target point? No, no. It is nearest, but not exactly to the target. Yes or no? Means I can say that this data point was getting some parameters where those parameters made it come nearest to my target. Yes or no? Now remember, the remaining ones are here. The remaining ones are here. Something like this. Now, to adjust your algorithm, you will try to consider the parameters for adjustment of which one. Now, because this is nearest to the target, I mean, there are some parameters that are making it reach the target. So don't you think that it is better we adjust all these data points with the parameters that are influencing this data point now, such that you can go nearest to that? So if you take a line, if you're taking a line of understanding, don't you think that it's nothing but a line that is expected to go in this direction to reach the target or not? So for these parameters, you should make them come onto this line. For these particular parameters, you should make them come on to exactly the center of the line. So adjusting these parameters to this particular line is nothing but the gradient descent. Are you getting me? Now, do you have any mathematical formula for making this happen directly? By putting that formula you can achieve? No. But I think gradient descent is something you could have learned in your geometry. Am I correct? Go back and recollect your schools and colleges where you started drawing the graphs and charts where gradient descent was discussed. The second one is called as SGD, wherein gradient descent, what will adjust the parameter in the direction of the steepest decrease of the error function. Okay. Steepest decrease, the nearest to the target point. To that, you please start adjusting the parameters in that particular direction. Then you have your SGD, means stochastic gradient descent, which is nothing but a variation of the gradient descent that updates parameters based on a single training example or mini batch of examples, making it faster suitable for larger data sets. Means we'll divide our corresponding training example and we divide the data into smaller batches, and with each batch we will try to go through the process. Means we conduct the experiments more number of times with lower amount of data. Am I clear? The third is called as Adam optimizer. Adam optimizer is nothing but a combination of both. Okay. So combines the advantage of both SGD and momentum based methods for more efficient optimization. Most of the time when you attend any interviews, they'll ask you, did you work with Adam optimizer? You say yes. Why did you use? Under what circumstances you use? Please, can you explain me algorithm where exactly you felt Adam optimizer is very important? Then we will have trouble. Mathematically, they are very simple. We can start. Okay. So fresh, I'll be starting gradient descent in tomorrow's class. Okay. We are getting the first level optimization technique, what we should learn. That is gradient descent. Okay. I'll be going with the construct of the definition, the corresponding points, what you need to catch up, the mathematical implication, and then we'll try to work with the construct of moving down with the algorithmic representation. And I'll take a program that can really tell you how you need to think of it. I think we are slowly getting into the process. So if I'm going with my construct of all these things, you need to just catch up. That's what, Satish. You need to go for multiple revisions on the video. Else you should go on. In one book, you will not get all this stuff. Remember, okay? So people cannot come like stereotyping. See, it looks scary when you are part of my sessions, but the fact you should understand and you should get ready for it. Got it? Savita, I will try that alternate, okay? Don't worry. But from tomorrow, you people are going to receive the link only for those people who are confirmed with their payments by the end of the day, man. Okay? Thank you very much, gentlemen. Once again with you tomorrow. Have a nice day. Take care of yourself. Have a great day. Good night. Have a nice weekend.